So first of all, column is for a compression member. Effective length 3 into least lateral dimension. Least lateral dimension means you can see here. Here's a Microsoft whiteboard. It's a column. Okay. Just wait a second. Here is a column. We have a column dimension, depth and width. So least lateral dimension means what? Minimum dimension. Minimum dimension between these two, depth and width, same as a beam. Okay, so it's called the least lateral dimension into 3. Into 3, it's called column. Okay, normally column are subjected to axial compressive force, means only column we have a compression force only, but sometimes column may be subjected to moment about one or both the axis. Okay, sometimes we have a moment on the column, but regularly we have only compression. What is pedestal? Pedestal is compression member, effective length less than 3 into least lateral dimension. Okay, pedestal design as a compression block without reinforcement, means in the column we have a reinforcement, but in a pedestal we have no reinforcement. Okay, we can provide minimum reinforcement. We can provide minimum reinforcement. Now we have a type of column. Type of column. Column may be classified as per shape, bracing, lateral, longitudinal reinforcement, and length. Okay. First is as per shape. So as per shape, we have a type of column as per shape of square, rectangular, circular, T shape, L shape. Let's check out. Here is a square. It's a square. It's rectangular. It's circular. It's L shape. It's T shape, and it's swastik. Okay. These are the based on the shape. Second is type of column as per bracing. We have a two bracing, braced column and unbraced column. What is braced column? In a base frame, lateral loads. In a braced frame, lateral loads like wind, earthquake, etc. are resisted by some special arrangement like shear wall, bracing, etc. Unbraced column, there is no special bracing system are provided to resist horizontal force. So in the bracing system, it's a column. Okay, it's a column here. One more column I can write. Okay, here is a floor. Okay, it's a floor. So we have to resist a horizontal force. Okay, and sometime we will build a shear force here. It's a shear wall. Here is a shear wall which is used for resist a horizontal force like wind, earthquake force. So this type of force we use for the resist. We use for the raising by bracing system. Next, tied column, untied column. Tied column, spiral column, composites column. Okay, when lateral ties are provided. Lateral ties means a stirrups. It's like a stirrups in a beam. So lateral ties provided we call as tided column. In a spiral column, we have a column like a spiral shape. Okay, and composites column. Okay, in this section we use a steel structure in a composite column. I can explain it in the figure. Here is a column. Okay, it's look like a column. So here is the column, we have a reinforcement. It's a longitudinal reinforcement. Okay, so in the column we have a tide, means here, 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 here. Okay, it is type called as tided column. In a second we have a spiral column. Okay, in a spiral column we have a longitudinal reinforcement. Okay, but tide is looking like this in a spiral shape. Our longitudinal reinforcement covered by a wire. Is like a wire. Okay, our four longitudinal reinforcement is covered by a wire. Okay, so this type of called a spiral. And one is composite. In a composite, this type of H shape, or sorry, I shape section, we have steel section, is covered by a concrete. Okay, so this type of shape is called a composite structure, means we have a steel structure in a concrete. Next we have a two more column, long column and short column. If LE by D, if LE by capital D, LE means effective length, LE means effective length of column, and D means depth, is more than 12, is more than 12, the column is called a long column. Okay, and for the short column, if LE by D ratio is less than 12, then column is called a short column. Remember this ratio, greater than 12 is long, less than 12 is short. Okay, okay, here are some requirement like reinforcement. For the longitudinal reinforcement shall not be less than 0.8 or shall not be more than 6. So in between we can provide 8% of steel or 6% of steel. Then after minimum longitudinal reinforcement, 4 in a rectangular column and 6 in a circular column. Okay, minimum numbers of longitudinal reinforcement. And bar shall not be less than 12 mm in diameter. Longitudinal reinforcement shall not be less than 12 mm in diameter. Okay. Spacing of longitudinal bar measured along the periphery of the column shall not exceed 300 mm. Between the longitudinal bar spacing, it's not exceed 300 mm. Okay. Less than 300 is valid, but not more than 300 mm. Okay. Then after lateral ties, we have called is pitch. Pitch means spacing between the lateral ties, which called is pitch. So least lateral dimension of the composite member, or 160 into smaller diameter of longitudinal bar, or 300 mm. It's the spacing. It's the spacing. Second is diameter, 1/4 of diameter of largest longitudinal bar, or 600 mm. Okay, these are this condition for the stirrups, lateral ties. Okay, Okay, here is a short axial loaded column. So in the short axially loaded column, you can see here is your column, here a reinforcement. Okay, so pu means total force. Pu means total force, and pc means concrete, force on a concrete, and ps means force on steel. So total load applied on a column, some parts is resist by concrete and some parts is resist by steel. Okay, so by this phenomena we can call this pu is equal to pc into ac plus ps into as. AC means area of concrete and as means area of steel. Means total shear force is resist, how much resist by a concrete and how much resist by a steel. It depend on area of concrete and area of steel. Okay, and then here is equation: when minimum eccentricity 0.05, then this equation use pu is equal to 0.4 fck ac plus 0.67 fy asc. For the axial loaded column, eccentricity is 0. When for the axial loaded column, eccentricity is 0. So pu is equal to 0.4 fck ac plus 0.67 fy asc. Remember this equation, we can find it from the IS 456 2000, page number 71, clause number 39.3. Okay, 0.4 fck ac plus 0.67 fy asc. Now we starting our example. In the given data we have a short RCC column of size 300 mm by 400 mm is reinforced with 6 bar 20 mm diameter. Determine the safe load of column can carry if M20 grade of concrete and Fe 250 steel is used. Also find the spacing of lateral ties and draw required sketch. So let's start. First of all, we have to find given data which is given in the example. So first we have FCK is 20 Newton per mm square. Second, Fy is 250 Newton per mm square. We have this two. Okay, M20 FCK is a grade of steel concrete and Fy is grade of steel. Now we have AG. AG means gross area of column. Gross area of column means dimension of column. Column dimension is 300 by 400. So its dimension is gross section area is 300 by 400. Okay, these are the gross column area. But in the gross column area we have area of concrete plus area of steel. Okay, so find out we have area of steel. In the given example, we have a 6 bar of 20 mm dia. Okay, 6 numbers of bar of 20 mm dia. So 6 into pi by 4 into 20 whole square. So ASC is 1885 mm square. What is this? It's ASC. So AG is equal to AC plus 1885. So we can find out AC. 1 2 minus 1885. AC is 11815 mm square. These are the area of concrete. Okay. Now we have a what we find out. We will find out a safe load on the column, which column can carry. So we have a simple equation here. PU is equal to 0.4 FCK AC plus 0.67 Fy ASC. We have the all value here 0.4. Okay. FCK is 20. ASC we find out 11815 plus 0.67 into Fy. Fy is 250 into ASC. ASC is 1885. Okay. So by this equation, by this value, we can find out PU is 1260657.5 Newton. But I want it in kilonewton. So 1260.65 kilonewton. So here is a safe load which can carry by column. Okay. Now one more thing is here. Also find a spacing of lateral ties. And draw required sketch. Okay. Now we are go on the next page. Our PU is 1260.65 kilonewton. It's a factor load. So we need a safe load is equal to PU divided by 1.5. So 1260.65 divided by 1.5. So value is 840.43 kilonewton. Okay. This is the value of safe load. Now we have to find the diameter of bar lateral tension. I use here for find diameter of lateral ties, and here is we can find out pitch. Now first of all, diameter ties, we have a two condition here. First is 1/4 into least I can write it out. Least diameter of longitudinal bars, and the second condition is 6 mm. Okay, so put the all value here. So first we got the value is 1 by 4 into 20. So is a 5 mm. So we can provide diameter of bar is 6 mm. So write down provide 6 mm dia bar. Okay. So in the pitch we have what three conditions. First, least lateral dimension. Second, 60 into diameter of bar, and the third one is 300 mm. So Leicester dimension is 300 mm of column. Okay, and diameter bar 60 into 20 is the value is 320 mm. So we can use a minimum diameter here. Okay, so write down provide 6 mm dia bar with 300 mm center to center. Okay, our design is completed here. Now we have to draw a cross section. Not clear canvas. Now first of all, it's a column. It's a longitudinal bar, and here is a lateral ties. Okay, now write down longitudinal bar at 6 mm 20 mm dia. Okay, it's too small. Second, lateral ties. Lateral ties is 6 mm dia at 300 mm center to center. Okay, here is elevation. Now we are going to draw cross section. Okay, three hundred mm D 400 mm. We have a 6 dia. It's a longitudinal diameter. Okay, longitudinal bar. Now here is stirrups. Okay, so here is a cross section of column. So our column design is completed. First, analysis of column. Now we are going to on the second example. RC short column square in a section. RC short column square in a section. Axial load 2000 kilonewton. Use concrete grade M20 and steel grade Fe415. Assuming 2% of the longitudinal steel reinforced. Means in this example we are going to design a column. But first case we have axial load here 2000 kilonewton, means pu is given, concrete grade fck20, steel grade 415 fe, and 2% pt is 2% is given, and size of we have to find out size of column, means we have a square column here. Second, area of longitudinal reinforcement. Third, pitch and diameter of lateral ties, and draw sketch of sectional elevation and plan. Okay, so let's start. This is the second example here. Second example, in the second example we have a pu which is 2000 kilonewton. Okay, pu is 2000 kilonewton. Second is fck 20 newton per mm square. Third, fy 415 newton per mm square. So this is the given data. And one more thing, we have pt, percentage of steel, which is 2%. So this is the given data. Okay, now we are going to design a column. So first of all we have to find out area of concrete, sorry, area of steel. So we have area of ASC is equal to 2% of area of gross. So it's 0.02 Ag. Okay, means gross area is column is fixed. In the gross area we have provided 2% of steel. So 0.02 into Ag we can find out area of steel. Now we have an equation here. Ag is equal to AC plus ASC. So AC is equal to Ag minus ASC. So Ag is minus 0.02 Ag. So AC is equal to 0.98 Ag. Okay, this is the given value which is we find out here. Now we have equation of pu. Pu is equal to 0.4 fck AC plus 0.67 fy ASA. Okay, so we have pu is given 2000 kilonewton, but I need in sorry the green value is okay. So pu is 2000 into 10 raised to 3 for the newton. So 0.4 into fck 20 newton per mm square. ASC is 0.98 Ag plus 0.67, Fy is 415, ASC is 0.02 Ag. So our value is 2000 into 10 raised to 3 is equal to 7.84 Ag plus 5.561 Ag. So by this value in the grading mode, okay, yeah. So we can find out Ag, area of gross 149242.6 mm square. Area of gross we have a square column. Now we have a square column. So for the square column we have a size of column is equal to under root Ag, area of gross. So under root 149242.6. So area of gross is 386.32 mm. These are the one dimension of column. So we can provide 390 mm by 390 mm size of column. Okay, these are the size of column. Now we can design a structure. So first we have find out first is size of column, second is area of longitudinal reinforcement. How can you find out? We have an equation here. ASC is equal to 0.02 Ag. This equation, so put the value 0.02 into Ag, total area provided. Look at here, we need a area provided which is 152100 mm square. So area provided is 152100. So AC is 3042 mm square. Okay, here is ASC, area of steel in a column. So area of steel in a column we can provide 4 numbers of bars at 28 mm dia and plus 4 numbers of bars at 60 mm dia. Okay, these are provided. So provided ASC is 3267 mm square. Okay, these are completed here. Now we have find out diameter of lateral ties. First, diameter of lateral ties. Okay, we have two condition here. First is 1/4 into dia of least bar. Okay, so 1/4 we provided 60 mm diameter. Sorry, not least, largest. So 28 mm diameter we provided. So is 7 mm. And second one is 6 mm. So provided larger of 2. So we have a diameter is 8 dia bar is provided. Why 8 mm? Because in the market we have a 8 diameter bar. There is no 7 diameter bar is available in the market. Okay, that's why we provided 8 dia bar. And the second one is pitch of lateral ties. In the pitch we have a 3 condition here. Least dimension is 390 mm. Second, 1 by 60 into diameter of bar is 60. No, not 1 by 60. यार ये गलती क्यों कर रहा हूँ? 60 into 60. So value is 256 mm. And the third one is 300 mm. So we can provide spacing is smaller of these two values. So provided 250 mm spacing means pitch. Okay, so our all design is completed. Now we can draw a dimension. We can draw a sketch. So first okay, its elevation, its elevation. Here is a longitudinal bar. Longitudinal bar which is 428 dia plus 416 dia. Okay, and here is a lateral ties. Lateral ties is 8 dia at 25 center to, sorry, 250, not to 25, 250 center to center. And here is a RCC column (390 by 390 mm). Okay, it's the elevation. Now we have to draw a plan. Okay, now we have 8 reinforcement. 1, 2, 3, 4, 5, 6, 7 and 8. Here is a longitudinal bar. Okay, and here is a ties. It's a ties here, and one more tie is like this. Okay, here is dimension is completed. Our 390 mm, depth is also 390 mm, Here is a longitudinal bar 4 bar 28, 4 bar 28 and 4 bar 60 dia, and here is a lateral ties 8 at 250 center to center. So our design is completed. It's a plan. Okay, the first one is